Hi there, and welcome to this lesson on Pure Mathematics 1. And in this lesson, we'll be considering how you make sketches of reciprocal curves. Now, the simplest form of reciprocal function is something of the form y equals a over x, some number divided by x. So, for example, if you had to sketch the curve of y equals 1 over x, first of all, we'd find the crossing point on the axes in the normal way. Find the crossing points on the y-axis. We say what happens if x equals 0. And if x equals 0, y equals 1 divided by 0. Now, division by 0 is not defined. It's not possible to divide by 0. Therefore, there are no crossing points on the y-axis. If we try to find the crossing points on the x-axis, rearranging the function gives us x equals 1 over y. And the same thing happens again. If y equals 0, then x equals 1 divided by 0. It's not possible to divide by 0, therefore there are no crossing points on the x-axis either. So the curve never touches, never crosses either of the two axes. The lines x equals 0 and y equals 0 are important though. So x equals 0 is the y-axis, y equals 0 is the x-axis. They're called asymptotes because the curve can get closer and closer and closer to them, but it never actually touches them, never reaches them. An asymptote is a line which the curve of the function can never cross or touch. Okay, we'll do an example. So coming back to y equals 1 over x. We know it doesn't touch any of the axes anywhere. To find the shape of the curve, it is helpful to consider what happens as the curve approaches the two asymptotes. So first of all, considering the asymptote at x equals 0. What we do is we ask what happens as x gets closer and closer to 0. We know it can never equal 0, but what happens as it approaches 0? And we need to consider what happens as x approaches 0 from either side of the y-axis. So from just beneath it and from just above it. First of all, we'll consider what happens as x tends towards 0 from above. That's the way you would read this. As x tends towards 0 from the positive side. Well, as x tends towards 0 from above, x is getting smaller and smaller and smaller. You'll have y equals 1 divided by a smaller and smaller number. Y is going to get bigger and bigger and bigger without limit. And if x is positive, then y will be positive as well. So as x tends towards 0 from above, y tends towards plus infinity. What about as x tends towards 0 from below? So it's getting closer and closer towards 0, but from the negative side. So it's a very, very small negative number. 1 divided by a very small number is a very large number. 1 divided by a very small negative number is a very large negative number. So as x tends towards 0 from below, y will tend towards minus infinity. Now, what does that look like? So on a graph, these two statements we could draw as this. So this part here is saying as x tends towards 0 from the positive side, y just gets bigger and bigger and bigger without limit, heading towards the y-axis, but never quite reaching it. And down here, as x tends towards 0 from the negative side, y is heading down towards minus infinity. Again, getting closer and closer to the y-axis, but never actually reaching it. Okay, now we'll consider the asymptote at y equals 0, which is the x-axis. We ask what happens as x gets bigger and bigger and bigger, as it heads towards the right-hand side. Well, as x tends towards infinity, again, we need to consider both plus infinity and minus infinity, considering plus infinity first of all. So as x gets bigger and bigger and bigger, you've got 1 divided by a bigger and bigger number. So y is going to become smaller and smaller. Now, if x is positive, then y will be positive as well. So y is going to become smaller and smaller, but positive. And the way we write that down is we say y tends towards 0, but it will be a positive number. So it's tending towards 0 from above, from the positive side. As x tends towards minus infinity, we'll have 1 divided by a very large negative number, which is again tending towards 0, but it will be a negative number. So this time, y does tend towards 0, but from the negative side. It'll be a minus number. What does that look like on the graph? So adding on those two statements will give us this point here. As x is getting bigger, y is tending towards 0, but from the positive side. Whereas here, as x is tending towards minus infinity, y is tending towards 0, but from the negative side, which is what we've written here. Now we know the graph never touches the graph, never crosses the graph. Also, nothing strange does happen between these two places. We can sketch the curve now, and it will look something like that. So that's y equals 1 over x. Now, all functions of the form y equals a over x have exactly the same appearance. 1 over x, 2 over x, 3 over x, 4 over x, they all look the same. As with quadratics and cubics, there are two possibilities, purely depending on whether a is a positive number, 2 over x, or a negative number, minus 2 over x. First of all, if a is a positive number, then y equals a over x looks exactly like y equals 1 over x. It'll have that general shape. Now, if a is negative, then what happens is the whole graph reflects in the x-axis. So this part here will reflect down, and this part here will reflect up. And if a is negative, then you will get something like that. So those are the two possibilities. If a is a positive number, the graph will look like this. If a is a negative number, then the graph will look like this. The other function that we have to consider is y equals a divided by x squared. Now, x squared is always a positive number. So a divided by x squared will always be positive as long as a is positive. And again, y equals a over x squared, they all have the same appearance. It doesn't matter what number a is, whether it's 2, 3, 4, or 5. Again, there are two possibilities, depending on whether a is positive or negative. If a is positive, then the function will look something like this, similar to what we had before, except this negative part has reflected upwards because x squared gives you a positive value. So 1 over x squared, 2 over x squared, 3 over x squared, they would all have that general shape. What about if a is negative? Well, same as before. If a is negative, you're multiplying by minus 1, and what that gives you is a reflection in the x-axis. So both of these halves will reflect down beneath the x-axis, and you get something like that if a is a negative number. So those are the two possibilities for a over x squared. If a is a positive number, then the graph will look like this. If a is a negative number, it will look like this. What about if you do change the size of a? What effect does it have? The general shape's exactly the same, but what happens if you increase a in size? Well, if a increases in size, the graph just gradually moves further and further away from both the x and the y axes. So for example, if you had y equals 1 over x, the graph would look something like that. If you had y equals 2 over x, same shape, but a bit further away from the axes. Y equals 4 over x, same shape, but again, it's just moving further away from the x and y axes as the value of a increases. Okay, some examples for you to have a go at. Exactly as I was doing there, sketch each pair of graphs on the same diagram. So for question 1, sketch y equals 1 over x and y equals 3 over x on the same diagram. And all you have to do is just give the general impression of which graph is closer to the axis, which graph is further away. Anyway, I'll let you have a go. So pause the video, have a go at these, and then come back again when you're ready. Okay, let's have a look. So the first one is just y equals a over x, where a is a positive number. Well, we know the general shape of that. So y equals 1 over x would look something like this. Y equals 3 over x, same shape, but further away from the axes. Something along those lines would do fine. Second question, y equals minus 2 over x. Well, minus 2 over x minus a over x always has this general shape. And if we have to draw y equals minus 5 over x on the same axes, again, same general shape, but a bit further away from the axes. You'll get something like that. The third question is of the form y equals a over x squared. Well, that's where the function has to be positive. So it's got to be above the x-axis. 1 over x squared would look something like that, where both halves are positive above the x-axis. 4 over x squared, same shape, just further away. Question 4, y equals minus 3 over x squared. Well, the same as we had just now, but now it has to be negative. So it has to be beneath the x-axis. Minus 3 over x squared would look something like that. Y equals minus 7 over x squared, same shape, but further away from the axes. And that is what you would get. Okay, that gets us to the end of this lesson. If you have the textbook, then turn to page 63 and have a go at exercise 4B. Thank you very much for listening, and cheerio.